Hello. In this episode, we're going to continue our study of urbanization and development. And in this, look at the issue of rural to urban migration that has been occurring at an unprecedented scale throughout the developing world, especially in South and East Asia. And so in this, we're going to also have some foreshadowing of our analysis about problems for development in rural areas, which we will examine in detail when we get to chapter 9. So policy views about rapid rural to urban migration and urbanization have varied over time. Started with a fairly positive view, then went to a rather negative view, and I think there's more of a balanced middle ground today, you could say. But still, it's true that for many countries, and this is especially notable in sub-Saharan Africa, that migration is greater than the urban area's ability and capacity to create jobs on the one hand and provide social services on the other hand. So this creates some questions for us, and we want to look at them further in an analytic way. The Harris-Todaro migration models have been the main framework for thinking about rural to urban migration. Starting out in a relatively simple framework, these models have been developed to encompass a wide variety of possible assumptions. The first thing is that it assumes migration is a rational decision. That itself was not an originally widely held view necessarily, that there was a lot of attraction to the bright city lights or the music and so on of the city. Indeed, urban amenities are significant, but the main motivation of moving from rural areas to urban areas, at least initially, does have essentially to do with the income differential. And in fact, that's exactly the issue. Compare the incomes that you could get in rural areas with those that you could get in urban areas, but don't necessarily get. Hence, we're interested in the expected values. So we're interested in the probability of getting a city job, and that's inversely related to the urban unemployment rate, naturally, that as the urban unemployment is higher, the chance of getting a job is less. And so that high rates of migration, potentially higher than would be efficient, are the outcomes of these rural-urban imbalances in the basic starting framework of this model. The simplest way of writing down this model assumes there's no urban traditional sector at all, though as we know already from our study of urbanization in developing countries, that sector is quite important. But we're just going to start out for simplicity by basically assuming that if you work in that sector, your wage is so low that we'll call it, for now, zero. And so this is an equilibrium condition, let me emphasize. It's not something that always holds with equality. On the left-hand side, we have the agricultural wage. It may or not be a wage, but we'll call it the W, the income you get in the agricultural sector. Perhaps A stands for alternative, as it sometimes does in economic development models. It's your alternative wage in comparison to going to the city. And so the question is, how does that rural income that you would get compare with the likely urban income that you would get? So how do we find this? Well, first of all, we consider what is the modern wage in the city if you were to get it. And we'll assume that that's fixed and given for now. And indeed, throughout this analysis, we'll make that assumption. This bar over the W says we're going to imagine this is fixed. It could be fixed for many reasons. It could be minimum wages. It could be union power. It could also be the rational motivation of firms, especially foreign firms, but domestic firms also, to pay higher wages in order to make sure that they attract the large pool of workers that they need in order to find the ones that are the most productive. And so LM is the number of laborers in this modern sector. You can think of it as the number of urban jobs. Whereas LUS is the labor supply in the urban areas in this notation. But you can just think about this as jobs over job seekers in this urban area. Well, let me give you an example of this. Let us, first of all, just think of this as being jobs over job seekers, because I think that's kind of intuitive. And let's just make up some numbers. If you stay in the rural sector, we'll just assume you get an income of 1. We can be comparing this on a daily basis, which adds up in a certain way. Could be an annual basis, so this could be 100,000 rupees a year, which would be $3,500 or so. In the rural sector, we will just suppose for the moment that there's a 1 in 4 chance of getting a modern job. 1 in 4 chance. And that is, in this view, telling us that there are 4 people looking for one of these nice modern sector jobs for every one that is actually available. And so the question is, are these things equal? This is the equilibrium. The question is, are they? So the question is this, then greater than, equal to, or less than, that's the question, of jobs over job seekers, that's 1/4 in the simple numbers we're using here, and let's say you get $3. If you are successful, maybe it's 300,000 rupees, but this is just equal to 3/4. So in this case, the expected value of the urban income, if you migrate, is less than the expected value or the actual value of the rural income. And so this predicts that you will not migrate. If this number were larger, such as 2, it would predict that you would. So that's how this analysis works. So for this simple model that we just looked at, as I mentioned, it really assumes that the traditional wage is equal to 0. Of course, it's not. People would die otherwise, right? It assumes there's only one period. Generally, though not always, the longer you have spent in the city, the greater your chance of getting a higher paid job. Maybe just because you know where to look, maybe because you've built up some social networks, maybe you've seen what skills are needed and found some way to get the skills. It assumes income is the only thing that's valued, not amenities. It assumes risk neutrality, which is not completely realistic, so we can make an adjustment for that. It assumes an equal probability that each job seeker will find a job, and clearly that's not the case, so we need to make this dependent on education, for example. It assumes that the rural or agricultural income is known with certainty, such as just giving it a value of 1. In reality, we have to consider expected area and income in that area of the economy also, such as maybe there's a drought or exceptionally good growing conditions. Assumes no moving costs, assumes that everybody migrating is going to seek a modern sector job and not especially nice, somehow traditional urban jobs, which in fact does happen. And all of these, or at least most, really all of these assumptions can be relaxed with more elaborate models. Just to illustrate this in an important example of doing so, we can relax the assumption that the traditional wage is equal to 0. And so, how do we do this? The details you can find in chapter 7 in footnote 34. Here are the pages, but I'll just show you how it looks. The informal sector wage now, rather than just being 0, we'll call the wage W urban informal wage. Maybe it's what you get selling stuff on the street. So you have to consider this amount times the probability of receiving it. So probabilities have to add up to 1. There are 2 possibilities. One is that you get a modern job, and the other is that you end up in this informal sector activity. So the probability of not getting your preferred urban formal wage is the probability of ending up in the informal sector. 1 minus jobs over job seekers. So we multiply the wage that you would get in the informal sector, of course it's often self-employed income, times the probability of getting it. And these two probabilities have to add up to 1. And it's worth emphasizing that these are separate and distinct activities. You need to keep in mind that you cannot do both. If you work very long hours in your modern job, maybe it's a factory job, you don't have the time to go also out at the same time on the street and sell stuff. So then the equation becomes a little bit different. We're still assuming that you just know the wage. In the rural area, it's 1 or whatever. But you are comparing that, and this is an equilibrium value. This equal means this is what would happen in equilibrium. It doesn't mean that we're necessarily in equilibrium. But our total expected urban income is as follows. The first part looks basically the same. It's jobs over job seekers times whatever that modern wage is. But the second part that we're now adding is the remaining probability, the 3/4 probability, let's say, that you don't get the modern job times that extra income. Before, we were assuming that in effect, the wages in the traditional sector were so low and that we would just call them 0. So it wasn't like the first equation was wrong. It just made the assumption that this value was 0. So this part of the equation went away. So here's a simple illustration of this idea, which is still the basic Harris-Todaro model. The rural wage is $1.50 a day, call it, or maybe it's 150,000 rupees a year. The urban modern wage is $3 a day, or 300,000 rupees a year, or something. The urban traditional income is $1/4 a day. So now we're just going to imagine there's a 0.5 probability of getting a modern sector job. So there's twice as many job seekers as there are jobs, say. Is there going to be migration? That's the question. So what you do is calculate urban income and you compare it to the rural income. And again, the important thing is you cannot work in the two sectors at the same time. You'll get the wrong answer if you do that. So that the expected then urban wage is equal to this 0.5 chance times 3, or that's 1.5. And notice we've already gotten up to the rural wage, but now also there's a 50% chance of at least getting 1/4. And so the result overall, adding the two, is that $1.62.5 is your expected urban income, which is greater than this $1.50 rural income. It shows we're not in equilibrium. And so the prediction is that the individual who makes this calculation is going to migrate. And importantly, even though half receive just this small fraction, 0.25 rather than 1.5 in this illustration, of their potential in the rural area. And so we can also further elaborate this model, incorporating the presence of different wages for 3 or more activities. I won't do that here. You can incorporate income for future periods in various sectors with the appropriate discount rate or discount factor. And so, for an example, the value of income in the next period might be 90%, but not 100% of what we look at in the future, so that $1 in the future may be worth 90 cents to us from today's vantage point. Also, there's a question of aversion to risk. If you were averse to this risk of urban unemployment, in which, after all, you're ending up with such a small income, smaller than even in the rural area, that may very well affect the wage that you're willing to work in the rural sector. So then there's some more details, but let me give you an example, I think, of this. Let us consider, first of all, that we might have, again, maybe 1 or 3. 1 is your income in the rural area. Now I'm just going to say 3 in the urban area. Let's suppose that you have a 1 in 4 chance of getting this modern job that you would really like. And so the question is whether this rural wage is greater than, equal to, or less than your 1/4 chance at your value of 3, and that's equal to 3/4. So the answer is no. If this is the story, we don't migrate as before. But maybe this is the first period. It could be a year, but let's call it, the next 15 years even, something like that. But in the future, after having been in the city for a while, maybe years, maybe you can get more chance of this job. But on the other hand, you may value money in that future period less than now, as is normally the case. So let's say then that there's also a second period, let's call it, in which there is a 1 in 2 chance. 1 in 2, let's make it. A 50-50 chance now in that future time. But we also have to think about discounting. So we'll have a discount factor. And we'll call that 0.8. So in other words, $1 in the future is worth 80 cents to us now. So now we're looking at basically the present discounted value and comparing them. And for the rural areas, that is 1. That's our original income in the rural area. We'll assume these values stay the same. Now we have to add in the value that you would get in the future in the rural area. Always keep in mind you need to discount income wherever you might get it, so you have to also discount your future income of 1. So we have to add to this 0.8, or 4/5 of this value of 1. Now the question is whether this is greater than, equal to, or less than our new urban expected value. Well, the value in the first period is 0.75, just as it was before, but there's the second period too. So we have to add in for the second period. Now let's first put in this discount of 0.8 just to make sure we don't forget it. Then, now, we're going to assume that there is a 50% chance instead of a 25% chance of getting that modern job. And what is that income? That income is 3. Not select all. Okay, so what is this? Well, we have half of 0.5, that's 0.4 times 3, so that this part is then equal to 1.2, and overall then adding 0.75 we end up with 1.95. So then the answer is that in fact, looked at over a lifetime, this expected rural income of 1.8 is less than the expected urban income of 1.95. Now in this lifetime framework, we predict that this individual will migrate. So this is the kind of extensions that you can do. So there are some important limitations to the basic Harris-Todaro models, and they have to be elaborated on and considerably extended beyond their original framework, which they have been. So first of all, a limitation is it explains migration only of those with sufficient human capital to compete with modern sector jobs. So we need to have a more elaborate understanding of what's going on in urban areas, such as having more than 2 sectors, at least 3 or more. So that also in practice, this is an equilibrium model, but an economy might be nowhere near that equilibrium. The equilibrium is just giving you an idea of where the economy would be moving over time. So sometimes even the urban traditional wages are higher, even significantly higher at times, than the rural traditional wages. If that's the case, you expect a very rapid rural to urban migration, as has been seen, for example, in a few African countries. Moreover, urban wages can be relatively high, even without intervention. I mentioned this before, so that one can take that into account as well. So efficiency wages are paid. You pay people more, so they'll work harder, they'll employ their better skills, they'll work harder because there's more loss if they get fired. This can keep wages higher, as well as the need to get lots of applicants so you can figure out who the best possible people to employ are. Simple models work pretty well explaining some scenarios like Botswana, but don't really sufficiently explain more complex situations like New Delhi in India. So we really need this much more nuanced kinds of analysis, considerable generalization of the model to get an understanding of what's going on, for example, in the case of New Delhi. So we have to expand the concept of migration in general to those who are intentionally migrating to work in the traditional urban sector, which has been the case over time, also for the case of Delhi. Then we will turn briefly to the question about market failure. So migration is now understood as rational. People are making rational decisions, even if the outcome is regret. You would certainly regret it if you had moved and could have had $1 in the rural sector and end up with $0.25 in the city. However, it is still rational, so why would you need a policy? Well, the idea is that if your interest is in efficiency, you need to point to a market failure to explain or justify your policy, and indeed to design your policy so that it does respond to the market failure you have in mind. So what are these possible market failures? One is that there's negative externalities to cities, overuse of infrastructure, packed buses and so on, overcrowded schools, health facilities and so on. There could also be other negative externalities. There are negative externalities to rural areas too, and an example that we might not think of readily is that this process is drawing out those who might do the best good for the rural areas that they leave, because people who can take a long time horizon, younger, people who have a better chance of getting these modern jobs, are better educated, people who are more likely entrepreneurial and less risk averse, they might start businesses or activities in rural areas also. And so as a result, you're getting a loss of the people who might be most dynamic and help in rural areas. That's something to take into account or understand as a part of this process. If there's something that is in essence making it very difficult for those people to be effective entrepreneurs where they work, inefficiently large city scales, we talked about that a little bit in our analysis of urbanization, unemployed resources, literally the people are unemployed or at least underemployed, and other negative externalities from urban conditions such as health. It's very easy for us to think about in a COVID environment that crowded conditions in cities may well lead to literal contagion effects. And so general policies to address the market failures, on the one hand, reduce urban bias, and urban bias is a topic discussed in the first sections of chapter 7, discussed in the previous episodes. Programs of integrated rural development should also be encouraged. And so we want to reduce urban bias, and we want to address imbalances in the expected income opportunities if they're arising in particular because of some market failures. We should also take into account that an emphasis on the higher education expansion is also fostering agglomeration of people in cities, even if they don't have employment opportunities yet. Also, very importantly, encourage programs of integrated rural development also. Don't think you must only invest in cities or underinvest in rural areas. And this includes attention to more inclusive rural institutions, so that in particular, a reason why those rural incomes may be so low may not have to do really with the underlying productivity opportunities, but more to do with the institutions, an extractive institutions environment. And we'll come back to look at some of those problems when we get into a couple chapters later on in the text in chapter 9. But nonetheless, this is something of a preview of issues that we talk about there. So that reducing urban bias, policies that are distorting investments above what's efficient, moving them into rural areas and into urban areas and away from potentially in rural areas, and just in general the failure to invest in integrated rural development are part of what would lead to too much movement into the cities. I just want to end with one word. This too much movement into the cities is not a statement for all time. It has to do with the rapidity of migration before it's what's most efficient in the economy. In the long run, we know that economies that have become very high income are also those that are highly urbanized. For example, 85% urbanization in some cases. And so the question is not whether such economies would or would not be highly urbanized when they were very high income developed countries. It's really a question of what's most efficient and makes most sense for the people in that country on their way toward successful economic development. And so with that, I will end this episode.